So for those of you that are gone today and are listening to the video, we just finished our forever quiz. They turned it in their forever quoting. The derivative packet is due by the end of the day. The odds, you guys can go ahead and just put it in your tray. I'll check them and then get them back to you guys tomorrow. Remember, the evens are due by the actual AP. Plenty of time for that. Quick recap on what's on the backboard. What's due tomorrow? The practice exam. Could it be totally printed out? Yes. Could it be that you kept track of everything and clearly showed like number 1, number 2, and you just had the PDF saved? Totally fine as well. But it needs to be completely attempted and graded. That's okay. You have tonight. The answer key, it's in the practice exams folder. That did not work. I clicked on something wrong. Solutions. So when you go under solutions, you'll see the spring break practice, FRQ, and multiple choice solutions. Does that make sense? Okay. Coming back, I really apologize. I did not mean to totally clear this out. The first question that we had was 2, then 3, then 7. Okay, so then number 2. Okay, come on. Come on, buddy. Don't got time for this. Find any local minimum, so that's just looking for relative. We're not having to worry about endpoints or tables or testing the candidates or any of that. When you guys found the derivative, well, let's just go here. What critical numbers did you find for number 2? X equals 2 and negative 4. But in the interval, do I have to worry about negative 4? So then we should have just needed to worry about from 0 to 4, just looking at 2. What was the sign of the derivative, remember, of the derivative before 2?
It was negative.
And then after? Which means that there is a minimum at 2. But here's the struggle. It's not asking for the at, it's asking for the of. It's not asking for the x, it's asking for the y. So it's at x equals 2, but that is not the correct answer because you have to plug into and figure out what's the actual y value that is the lowest. What's the lowest at 2? Does that make sense? Yeah, because the minimum value. Good. 2 and 3. Next one would be number 7. Oh, no, just the original, because, well, we use the derivative to find the critical numbers, but they want the actual lowest value. Go find the y. Go back to the original. Number 7. You're trying to do implicit differentiation, true? Did you guys do the product rule with 2xy? Good. So we have 3x squared plus 2y plus 2x dy dx minus 6y dy dx equals 0. You had 0, right? And when you got dy dx alone, you would have factored, subtracted these two, negative 3x squared minus 2y, then divided by, when you factor out, 2x minus 6y. Now, there are tons of things they could have done. They could have pulled a negative out of the top and the bottom and then simplified. They could have pulled out a 2, but it wouldn't have reduced with anything up above. The one thing I see that they did is they did pull a negative out of the top and the bottom, aka you can think of it as multiplying by a negative 1. Because they saw this negative, they pulled it out. In order to cancel it, they also pulled this one out. Or you could think of it as multiplying top or bottom by a negative 1. And that should have matched with A, I believe. Oh, sorry. Yeah. When you pull them both out, sorry, it's a plus. I looked too fast. Number 15. (15, 16, 17). Hello. Well, that's fun. Let's say this then, to that end. And we only have a minute left anyway. I'm going to try and reload this, but let's go ahead and turn this in tomorrow. I'll spot check tomorrow. Sound good? That way you guys don't have to stress about putting it in the tray. We can maybe take a couple seconds at the beginning of class to go over these last few questions. I so apologize that the document was being done. We can still kind of peek at it probably pretty fast, but let's just not stress about getting it back in the tray. This is a graph of the original. So think y value, slope, concavity. Slope of all of these, this function is decreasing. The slopes will all be negative. That's the derivative. The concavities will all be positive. And then f of a is 0. So Negative should go, is it least to greatest? Negative will be least, then the 0, then the positive. Thinking concavity, increasing, decreasing. 16 was fun. 16 was fun. Because if it says that f needed to be concave up for all values 2 to 8, the sad thing is they didn't say about increasing or decreasing, so that was kind of a struggle. Concave up could happen for both a decreasing portion and an increasing portion. What's the point of concave up? Is that the rate needs to be increasing. So if the rate needs to be increasing, either negatives are getting less negative or positives are getting more positive. So if it's increasing, it can't increase by a set amount. That would be a constant rate, which would be a line. That wouldn't be concavity. That's why that one's out. This one is decreasing, which is okay for concave up. That would be like this. But it needs to decrease by smaller and smaller amounts. So this one decreases 4, and then it decreases 4, and then, 6, then it decreases, man, it's decreasing by larger amounts. That doesn't work. It needs to decrease by smaller amounts. So that one's out. This one's increasing. That increases 6, and then 4. That's it is B? I was going to say this one is increasing the wrong way. It's increasing by smaller amounts. This one's increasing 2, then 3, then 1. That's not going to work. But increasing 2, then 4, then 5. Booyah. One that is increasing, positives, increasing in a faster fashion. Anyway, that one was a party. Thanks, guys, for the extra 45 seconds. I'll spot check it tomorrow, but hopefully this is done and you can just focus on finishing up the practice exam.